Alright, next up we've got section A3 on factoring, and factoring a polynomial is essentially the complete opposite process of multiplying them together that we just went through in the last section. So the goal here is you're given a polynomial. Someone gives you a polynomial, and the question is, can I write this polynomial as a product? Can I write it as a product of other polynomials? At least two or more of them. And in general, this is a hard process. So we'll stick to fairly simple polynomials. We'll stick to degree 2 polynomials, usually one variable. I think we'll do one example today where we have two variables, but this can be hard, but we're going to go through sort of the cases that we can handle pretty well. So for example, here's a simple one. Factor 5x squared plus 15. There's a polynomial. Can I write this as a product of two or more polynomials? And you'll notice, because I'm sure you've done some factoring before, you'll notice that both of these coefficients are divisible by 5, right? What I mean by that is I could think of this as 5 times 1x squared, right? So 5 times x squared. And the second term, I can think of this as 5 times 3. Okay, so I have 5 multiplying both terms together. I'll never write the second step again, by the way. We'll just do this mentally in the future. But since both terms are multiplied by 5, I can factor out the 5. So I can write this as 5 times x squared plus 3. And now I've factored it, right? Now I've written it as a product of two different polynomials. 5 is a very simple polynomial, it's just a constant, but it is a product of two different polynomials. And moreover, we often talk about polynomials being fully factored, meaning that once you've written it as a product of polynomials, each of those polynomials in your product can't then themselves be factored any further. And this is fully factored. X squared plus 3 cannot be written as a product of two other polynomials. So this guy's fully factored. Alright, here's another example. Let's say factor 3m cubed plus 6m squared plus 12m. Okay, so what can I divide all of the terms by? What's common to all of them? Well, I could divide 3 by 3, 6 by 3, and 12 by 3. Right, so they're all divisible by 3, but I can actually divide them by a bit more than that. They're also all divisible by m, right? M goes into m cubed perfectly, m goes into m squared perfectly, and m goes into m perfectly. So I can divide by more than just 3. I can divide by 3m, right? So this first term is actually 3m times m squared. Right? If I multiply them together, 3m times m squared, I get right back to 3m cubed. The next term, 6m squared, is 3m times what? Times 2 to get 6, and times m. M times m gives me m squared. And last but not least, 12m is 3m times, I need 4 to get 12. And I already have the m here, so that's it. It's just 3m times 4. Alright, so if I were to factor this, well, I've got 3m common to every single term, so this is 3m times m squared plus 2m plus 4. And this polynomial is now factored, right? It's factored as one polynomial times another. Sometimes you'll still have stuff left in here that you can factor. Sometimes this expression, this polynomial, will be able to factor again. But in this case it doesn't look like I can, but we'll get to that. We'll get to that right now, actually. One more thing I'll say is in the future, again, this step right here, I won't usually write this step, right? In fact, I probably never will again. We'll just observe immediately from here, yeah, we can pull 3m out, so it must look like 3m times, and we'll do all the rest of the work in our head as we go through these things. Actually, yeah, before we factor trinomials like this, let me just point out a common factorization. really common factorization that's worth remembering, a squared minus b squared, usually known as a difference of two squares. Right? I've got one squared term minus another squared term, so it's a difference of two squares. This always factors, and it's worth just committing to memory exactly how it factors. It factors as a plus b times a minus b. And if you want, you can try distributing this now. You can FOIL this out, distribute this out, and you'll see that these do indeed multiply together to give a squared minus b squared. All right, so this is worth committing to memory, so you don't have to do this by hand ever again. So for example, let's say I had 4x squared minus y squared. Well, I know this factors now, because it is a difference of two squares. What are my two squared terms? Well, 4x squared is really 2x squared, right? 2 squared gives me 4, and x squared gives me x squared, so it's really 2x squared minus y squared. And what does that mean? Well, if I'm writing it in the form up here, one term squared minus another term squared, my a is 2x. Sorry, wrote that really small down there. A is 2x, and b is just y. So if I factor this as a difference of two squares, a is 2x, b is y, so we've got a plus b, 2x plus y, times a minus b, 2x minus y. And again, I urge you to check this. Check that when you multiply these together, when you FOIL these or distribute or whatever, just multiply those two polynomials together. Check that you do indeed end up back here at 4x squared minus y squared. You will, I promise. Alright, so lastly, we're going to factor slightly harder polynomials. Right? We've done actually fairly easy examples so far. Factoring what's called a trinomial. Factoring trinomials. And I'll just write out the algorithm here, or the process for going through this before we do an example. So to factor a trinomial, of the form, so what is a trinomial? Technically you're allowed to have a coefficient times x squared as your first term, but I'm just going to go with my coefficient being 1. So it would be x squared plus bx plus c. And so what does this mean? It's a polynomial. My coefficient in front of x squared is always 1. Coefficient in front of x could be anything, it's just some number b. And my constant term is some number c. So to factor a trinomial of this form, we look for two numbers whose sum is b. So I want two numbers that add together to give me b and multiply together to give c. So two numbers whose sum is b and whose product is c. And so, for example, let's say I want to factor x squared minus 2x minus 15. Okay, so what's b in this case? Well, notice this is of the form plus bx. Here I have a minus, so you can think of this, if you want, as x squared. Let me write an equal sign instead of a bracket, right? You can think of this as x squared plus minus 2x plus minus 15. All right. Again, I won't usually write this step, but just to be totally clear, that means my b in this case is minus 2. And c is minus 15. Okay, so now a bit of trial and error comes in. I'm looking for two numbers that add together to give minus 2 and multiply together to give minus 15. So a bit of trial and error, you'll have to think about this maybe, but the more you do, the faster you get, and I know that, well, let's see, what do I want? 3 and 5 certainly, how are they going to work? Let's do minus 5 and plus 3. Right, if you add them together, you get minus 2. If you multiply them together, you do get negative 15. So that's what I'm looking for. And how is it going to factor? Well, this factors as x plus the first number. These can be written in any order. So x plus minus 5, which I'll just write as x minus 5, times x plus the second number, x plus 3. Again, the order doesn't matter. Totally fine, just write this as x plus 3 times x minus 5. Alright, same thing. Either one of these is totally correct. So that's how you factor these trinomials, right? You look for two numbers, then add together to give you this coefficient, multiply together to give you that coefficient. And once you have it, you just have to remember how to write down the form. It's x plus the first number times x plus the second number. We'll do another example. Alright, we'll go to m as our variable. M squared minus 4m plus 4. Alright, so how does this factor? If it does factor, not all polynomials factor, by the way, or not all trinomials rather. They don't always factor, but if you can, it will factor as m plus some number times m plus some number. And what are these numbers going to be? Well, these numbers are going to be two numbers that add together to give minus 4 and multiply together to give positive 4. What are my two numbers going to be? Well, it turns out in this case they're actually minus 2 and minus 2, right? Minus 2 plus minus 2 is minus 4, and minus 2 times minus 2 is indeed positive 4. So this factors as m plus minus 2 times m plus minus 2. Which you could also write a little bit faster as m minus 2 squared. So this trinomial has been factored. Alright, we'll do one more example here. Last one of the section. We'll do sort of as hard as these get. We'll do an example of as difficult as these can be. Let's factor 8x squared plus 14x plus 3. So this one is more tricky than the previous examples. Why? Well, because I don't have a 1 here. Right? I don't have a 1 in front of the x squared like in the other examples we're doing. And the algorithm I gave you for how to factor trinomials was only for trinomials of the form 1 times x squared plus bx plus c. So how do you deal with this extra 8 in front? Well, there's two ways you can go. One is you can just factor out the 8, right? So I'd write this as 8 times x squared plus, if I pull an 8 out of 14, this would be 14 eighths left over. And an 8 out of a 3 would be 3 eighths left over, right? What do I need to multiply 8 by to get 3? Well, 3 eighths. Okay, so you could do this. And now you could continue factoring as we just were, right? Now you could look for two numbers that add together to give 14 eighths and multiply together to give 3 eighths. And you could factor just this polynomial here. It's doable, but it's kind of ugly in this example. And it's ugly because these are fractions, right? If I could factor out an 8 or whatever this number is and just have nice whole numbers here, sure, do that every time, right? It works really nicely, but I'm not going to go this route because it doesn't work very well in this case. So here's something else you could do is, okay, so I know if this factors, it's going to look like something times something else. And I'm going to ask myself, these first two terms together, when I multiply them together, right, there's going to be an x and an x. When I multiply these together, that's the only way I get an x squared term, right? So how do I get an 8x squared term? Well, two ways. I could either do 8x times x, right, 1 times x, or I could do I could do 4 times 2. Yeah, my brain totally froze there. I could do 4x times 2x. Right, 4 times 2 also gives me 8. And now it really is trial and error, right? There is no nice algorithm I can give you for how to do this. Plus something, and what I need is 2 numbers that multiply together to give me 3. Well, what multiplies together to give me 3, right? Because the last 2 numbers here, when I multiply them, I have to get this constant term. I have to get 3. What multiplies to give me 3? Well, really just 3 and 1, or possibly minus 3 and minus 1. Alright, so just trial and error here. I could try, okay, so 3 and 1, I could say, let's do plus 3 and plus 1, right? So if I multiply the first 2 terms together, I get 8x squared, that's great. If I multiply my last 2 terms together, I get the plus 3, that's great. But how many x's do I have? Well, I've got 8x times 1 is 8x, plus 3 times x, so 8x plus 3x is 11x. Well, that didn't work because I need 14x, right? And I could try the other order. I could try doing minus 3 and minus 1, or I could try putting the 3 and the 1 here. But you'll see that this doesn't work either, right? This gives me 24x plus x is 25x's. So this option isn't going to work. So if it does factor, it factors like this. It factors as 4x times 2x is my first 2 terms. And I'm just going to try something here, 3 and 1. So I've got 4x times 2x is 8x squared. My last 2 terms, or my last term is 1, 3 is 3 again. What do I have in the middle though? Well, 4x times 3 is 12x, plus 2x is 14x. So this is indeed the answer that I'm looking for. Right, so how do you factor these more difficult ones? Well, again, you ask yourself, how many ways can I multiply together to get 8? And we had 2 different cases, right? We had 8x times x, or 4x times 2x, and you have to think about both cases. And then, what numbers multiply together to give my constant 3 and 1? And we just went through trial and error. That's really all you can do is trial and error and try and figure out which way you can combine these to get the right amount of x's in the middle. By the way, something I haven't really stressed through this because every example we've done so far has factored. Not all polynomials do factor, right? You can't always factor. In these examples we've done, they do factor nicely, but you can't always. So I wanted to do one more example that looks like this. We won't see many examples like this during the semester. You'll notice this is slightly more difficult than anything we've done so far because it's a polynomial in 2 variables. I've got x and y. And notoriously, polynomials in 2 variables are pretty hard to factor. We can only handle them if they look if they take on a very specific form, which this one does. And the way I'm going to factor this is just sort of using this trial and error method that we were using. We can keep playing this game, and it'll work totally fine here. Full disclosure, there's a slightly better way to do this, but again, we won't see many examples like this semester, so I think this is fine. But let's see, how are we going to factor this? Well, I've got my leading term is x squared. The only way I'm going to get that is if I have something times x plus something times x. Right, and what are my possibilities here? Well, the only way to get a 6 is either do 6 and 1, or maybe 3 and 2, or 2 and 3. So those are our only real choices there. And at the end, I've got a 4y squared. Well, the only way I'm going to get a y squared is if I end up with y times y, and once again, some coefficients in front. And how do you get a 4? Well, you could do 4 times 1 or maybe 2 times 2. Alright, so I could try doing 2 times 2, or I could try doing maybe 4 and 1. Or plus or minus, right? If I chose minus 6, then I'd be choosing minus 1. So there's lots of possibilities here, right? This trial and error isn't necessarily the best way to do this, but you'll notice pretty quickly that my middle term, minus 25, is fairly large. Right? So if I'm going to get minus 25xy, I probably need to choose large numbers to multiply together. So that's gonna motivate me here. I'm going to choose 6. I'm going to choose 6x, which means if I'm choosing 6x for my first expression, then this must just be 1 times x. And I want a big number. I want lots of x's and y's multiplied together. So if I have 6x, I'm going to choose 4y here. Because 6x times 4y, that gives me 24xy. Right? Well, hold on. I don't want 24xy. I want minus 24xy. So instead of choosing positive 4y, let's choose minus 4y. And now we don't have a choice. Once I've chosen the 4 here, then I must be choosing the 1 for this coefficient, because remember I needed them to multiply together to give me 4y squared. So once I chose 6 here, that means I must have a 1 here, and once I chose minus 4 for this expression, that means I must have a minus 1 there. And you can check that this actually works. This gives me 6x times x is 6x squared, 6x times minus 4y is minus 24xy, minus y times xy is minus xy, and minus y times minus 4y is plus 4y squared. And that is exactly our original expression once you group these two like terms together. So yes, there's a lot of possibilities here, a lot of choices, because I'm just doing trial and error to figure out sort of what these coefficients could possibly be. But we won't see too many of these, so I won't worry too much about it. Alright, so we'll wrap up with two formulas here. I already gave you the formula for a difference of two squares, very common type of polynomial that you want to factor in practice. And you'll notice we really just kind of stuck to a lot of quadratic expressions today because factoring higher degree polynomials is notoriously difficult. But these pop up often enough that it's worth sort of committing them to memory as well. Difference of two cubes, so u cubed minus v cubed, and sums of two cubes, u cubed plus v cubed, and they factor in the following way. So they're hard to factor, so it's easier, much easier, just to commit these formulas to memory. And we'll do one example. Here's 8x cubed minus 1. And you'll notice this is a difference of two cubes, right? This is 2x cubed minus 1 cubed. So this really is a difference of two cubes. U is 2x and v is 1. So we're looking at something of this form, u cubed minus v cubed, where u is 2x and v is 1. So to factor it, now I just have to go to my formula. This factors as u minus v, so 2x minus 1. And then we've got u squared, so 2x squared. Remember, both terms get squared, not just the x. It's 2 squared is 4, times x squared is x squared. So this is 4x squared. U times v, 2x times 1 is just plus 2x. And plus v squared, so plus 1 squared is plus 1. And that's it. If you tried to factor this using any of our other techniques today, this would have been quite difficult for you. So this is one of these where sort of the difference of two cubes formula comes in and makes our life a lot easier. So we'll stop here. Thanks, guys.